Good morning everyone. Myself Usharani from CSC department. Now I am going to explain about stack concept in data structure. Before going to see this, first we should know about some basic concepts in data structure. What is meant by data structure? A way of storing and organizing data in the computer memory so that it can be processed efficiently. Now we have to classify the data structure into two categories. First one is linear data structure, second one is nonlinear data structure. Linear data structure means a data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent elements is called a linear data structure. Examples of linear data structures are array, stack, queue, etc. Second one is nonlinear data structure. Nonlinear data structure means data structure where data elements are arranged hierarchically. Examples of nonlinear data structures are trees and graphs. What is an array? An array is a non-primitive linear data structure used for storing elements of the same data type. The array elements gets contiguous memory allocation when stored. Each element in an array is assigned a position known as index using which it can be accessed. What is a stack? A stack is a linear data structure in which insertion and deletion of an element is done at same end called top. It follows last in first out or first in last out, as the last element which is inserted is the one that comes out first. Stack consists of two main operations. One is push operation, second one is pop operation. What is meant by a queue? A queue is also linear data structure in which insertion is done at one end called rear and the deletion at the other end called front. Queue follows FIFO, that means first in first out order. That means the first element which was inserted will be the first one to deleted. Queue consists of two main operations, NQ and DQ operation. Trees and graphs, these are comes under nonlinear data structure. What is meant by a tree? A tree is a nonlinear data structure in C. It follows a hierarchical pattern in which each node points to a number of nodes. The root node is the one which has no parent node, and the leaf nodes are the one which no child nodes. The basic operations that tree involves are: first one, inserting a data node into the tree. Second one, deleting a node from the tree. Third one, searching an element in the tree. Last one, tree traversal. What is a graph? A graph is a nonlinear data structure in C consisting of pair of V, E, where V is known as set of vertices and E corresponds to collection of pair of vertices called edges which connects any two vertices. The vertices are actually the nodes that have the data and pointer fields. A graph can be either directed or undirected. The main operations on graph are: first one, adding and removing a vertex in the graph. Second one, adding or removing the edge in the graph. Third one, searching for an element in it. Fourth one, checking if there exists a path from one vertex to another. Now briefly discuss about stack in data structure. Stack comes under linear data structure. What is stack? Stack is a sequence of items that are accessible at only one end of the sequence. The basic principles of stack is last in first out. These are the real-time examples of stack. What are the operations can be performed on stack? Push operation. Second one is pop operation. In push operation, adds item to the stack. In pop operation, removes items from the stack. Both the push and pop operations are performed at one end only. Push operation used to insert the items into the stack. Pop operation used to delete item from stack. Top represents the current location of data in stack. In the stack, if you want to push D, it will be pushed after C. Similarly, we can push E. If you want to perform pop operation, the item in the top of the stack will be popped out. Algorithm for push operation. When you come to algorithm, we have to check the stack overflow condition first. That is, check whether top of the stack equal to max size of the array. If the condition is false, we can insert the new item into the stack by increment the top pointer, that is top equal to top plus 1. Algorithm for pop operation. We have to check stack underflow condition, that is check whether top of the stack equal to 0. If the condition is false, the item in the top of the stack will be deleted and the top pointer is decremented. Applications of stack. First one is reversing string, second one evaluating arithmetic expression. In reversing strings, stacks can reverse strings by pushing each character onto the stack from left to right. Then popping characters of reverses the string since the last pushed is first out. For example, to reverse, read it left to right and push each character onto a stack. Second one is evaluating arithmetic expressions. We can represent the arithmetic expressions in three forms. First one infix notation, second one prefix notation, third one postfix notation. In infix notation, the operator will be in between the left and right operands. In prefix notation, the operator will be in front of the operands. In postfix notation, the operator will be after the operands. Next, I am going to explain about queue. Queue is another type of linear data structure which is used to organize the data. It stores data temporarily. A new element is added at one end called rear end and the existing element is deleted from the other end called front end. Its basic principle is FIFO, that is first in first out. Type of queues are, first one is simple queue, second one is circular queue, third one priority queue, and last one is DQ, double-ended queue. Simple queue. Simple queue means the simple operation of queue in which insertion occurs at rear end of the list and deletion occurs at the front of the list. Next one is circular queue. This is the structure of circular queue. The circular queue, all nodes are treated as circular. Last node is connected back to the first node. It is also called ring buffer. Circular queue contains a collection of data, which allows insertion of data at the end of the queue and deletion of data at the beginning of the queue. Next is priority queue. Priority queue contains data items which have some preset priority. While removing an element from a priority queue, the data item with the highest priority is removed first. In a priority queue, insertion is performed in the order of arrival and deletion is performed based on the priority. Next one is DQ, that is double-ended queue. In double-ended queue, insert and delete operation can be occur at both ends, that is front and rear end of the queue. What are the operations on queue? First one is NQ, second DQ, third is full, fourth is empty. In NQ operation, add an item to the queue. In DQ operation, remove an item from the queue. In useful operation, while adding an item into the queue, we have to check is full of condition. In is empty. While removing an item from the queue, we have to check is empty of condition. NQ operation. Check if the queue is full. If the queue is full, we cannot insert an item. If the queue is not full, we can insert an item by incrementing the rear pointer. Repeat the process till the last element is inserted. Algorithm for NQ operation. Check if the queue is full. If the queue is full, produce overflow error. If the queue is not full, increment rear pointer to point the next empty space. Add data element to the queue location where rear is pointing. DQ operation. Check if the queue is empty. If the queue is empty, it results in underflow condition. If the queue is not empty, access an item where front is pointing. Algorithm for DQ operation. Check if the queue is empty. If the queue is empty, produce underflow error. If the queue is not empty, that means condition is false. If the condition is false, we can delete the item pointed by the front pointer by incrementing the front. Applications of queue. Queue is useful in CPU scheduling, disk scheduling. When data is transferred asynchronously between two processes, queue is used for synchronization. Examples: I/O buffers, pipes, file I/O, etc. In real life, call center phone systems will use queues to hold people calling them in an order until a service representative is free. Trees comes under nonlinear data structure. Now I am going to discuss about tree traversal. Tree traversal means visiting each node in a tree. There are various ways to traverse tree data structures. That is pre-order traversal, in-order traversal, post-order traversal. Pre-order traversal. Pre-order traversal is a method of visiting all the nodes in a binary tree where the nodes are processed in a specific order. The first the root node, then recursively the left subtree followed by the right subtree. This traversal technique is particularly useful for creating copy of the tree for prefix expression evaluation. Algorithm for pre-order traversal. We have to visit the root, then traverse the left subtree, then traverse the right subtree. That is, the order is root, left, right. For example, consider this tree structure first. We have to consider the root node, then consider the left subtree. Here is the parent node, B is the parent node. Then left child and right child. Similarly for the right subtree, C is the parent of F, is left child, and G is right child. In-order traversal. In-order traversal is a fundamental method used to visit all the nodes in a binary tree systematically. This traversal technique follows a specific order. It first visits the left subtree, then the root node, and finally the right subtree. This approach is particularly useful for binary search trees because it retrieves the node values in ascending order. Algorithm for in-order traversal. First, we have to traverse the left subtree, and then we have to visit the root, and then we have to traverse the right subtree. That is, the order is left, root, and right. Example for in-order traversal. Consider this in-order tree structure. We have to consider the left child of left subtree. Here D is left child, and then traverse parent node B, and then traverse right child E. In this tree, left subtree is completed, then traverse A. Similarly, follows the right subtree also. Last one is post-order traversal. Post-order traversal is a depth-first tree traversal method where the nodes are recursively visited in the order left subtree, right subtree, and then the root node. This traversal is particularly useful for operations where child nodes need to be processed before their parent nodes, such as deleting a tree or evaluating expression trees. Algorithm for post-order traversal. First, we have to traverse the left subtree and then traverse the right subtree. Finally, we have to visit the root node. That is, the order is left node, right node, and then root. Example for post-order traversal. Consider this post-order tree structure. We have to consider the left child of left subtree. Here D is left child, then traverse right child is E, then parent is B. In this tree, left subtree is completed, then traverse right subtree. Now I am going to discuss about linear search. Linear search comes under searching algorithms. Need for searching algorithms. Searching 1 million items slows down as data grows. Efficient search algorithms are needed to speed up this process. What is mean by linear search? Linear search or sequential search examines each element in the list to find a specific value. The list does not need to be stored. The search takes elements one by one until the target is found or the list ends. It is a straightforward method based on sequential comparison. We search the array for 3, checking each item from the start. First value is not 3. Check the next element. Second value is not 3. Keep checking next elements. Check values one by one. Third is not 3. Fourth value is 3. Value found at fourth position. Linear search checks each item until it's find the target. Algorithm for linear search. Input array size and key value. Output index of key in D. In for loop, we have to check from 0th position to the end of the array. If D of I equal to key value, return the I value. Thank you.